This is part two of the lectures from Unit 7, Air Pollution. We're going to move through each individual of the six priority pollutants and then talk a little bit about photochemical smog and industrial smog. So starting with the six priority pollutants, particulate materials are simply particles that are suspended in the air that you can breathe in, and they can range from all kinds of different sources, soil particles, soot, lead, asbestos, etc. Even when you go to the ocean and you smell that ocean smell, that is suspended salt, particles of salt in the air. There are two kinds of particulate matters that are of concern in industry, PM10 and PM2.5. And the only difference are the number of microns in size, the minimum micron. So anything less than 2.5 microns is not something that industry worries about. PM10 is bigger particles, 10 microns in diameter. And by the way, a micron is 1/1,000,000th, 10 to the negative sixth of a meter. It's the same as a micrometer. So they are particularly dangerous. Soot is is considered a particulate and can do some significant damage to your lungs, including respiratory distress, bronchitis. Some particulates may include lead or other carcinogenic materials. This is the big problem with urban air quality in places like China and India. So when you see pictures like this is a picture from Beijing. You can see that the air quality was atrocious as late as no more than 6 to 8 years ago, 2014. And so you can look at some of this data down here shown in this graph. I know it's a little bit hard to see, but it shows sales of vehicles in China from 2000 to 2013. And vehicles, of course, burn. Diesel in particular gives off soot. And other particulates, which can react in air to cause photochemical smog, which is really terrible for your respiratory system. So the increase in air quality issues in China has corresponded with their rise as an industrial nation and the idea that one car per family is the norm in most industrial societies. Here's another piece of data that shows how terrible the air quality was in the early 2000s. This is 2010 data, and you can see that on the right is shown the top 10 worst air quality cities in the country. A lot of them in the United States. A lot of them are in California, and part of that is due to geography more than anything. This is the World Health Organization guideline, 10.0 micrograms per cubic meter, and that's micrograms of particulate matter per cubic meter. And you can see that the 10 worst cities in China are over 10 times that concentration. Whereas even in North America, even in the United States, there are some cities that violate that standard, but nothing compared to China. Now that has changed significantly. The air quality has improved radically in China since then, but there are still cities like Beijing that struggle with air quality. I'm going to go back one slide. We're going to look at I'll link this movie to my STA board. You can watch the first 10 minutes, 5 minutes of it or so. It's a 15-minute movie, but it just shows some video of how terrible the air quality is in parts of China. Linfen is a city that's about 500 miles southwest of Beijing. All right, moving along. Sometimes particulate matter includes lead. Lead was one of the top 6 priority pollutants banned in 1970. It, of course, causes some pretty impactful symptoms in the nervous system. It can cause slurring of the words, symptoms that look like Alzheimer's. The source used to be in gasoline. It was used as an anti-knock agent for your car's engine, but also, of course, coal burning emits lead and industrial metal smelting. So that was banned in the United States in the mid-1970s, but not in other places. It's still used as an additive to gasoline, so it still gets into the atmosphere and therefore is circulated globally, and we're all exposed. We've talked a little bit about NOx. It's it's released by burning fossil fuels. When nitrogen and oxygen, which remember is 99% of air that you breathe, when they react at high temperatures, it releases nitrogen monoxide or nitrogen dioxide. And both are highly reactive gases that contribute to acid rain, to smog, all kinds of things. So again, primarily the NOx is related to two things: transportation and industry. And where electricity generation is concerned, of course, it's coal burning and natural gas burning power plants. All right, moving on. SOx, sulfur dioxides, also a primary pollutant. Usually this is from coal emissions. Coal is a dirty fuel and contains sulfur as a mineral, iron sulfides. But that reacts with water in the atmosphere and causes acid rain. So about a third of the sulfur dioxide in the atmosphere, however, comes from part of the natural sulfur cycle. And the great majority of that is from volcanoes, volcanic emissions. Carbon oxides, two kinds to worry about: carbon monoxide and carbon dioxide, both priority pollutants, both are greenhouse gases. CO2 we've talked in great detail about. 93% of that is part of the natural carbon cycle, but some of it comes from us. And it's pretty amazing to think that just the 7% out of all the CO2 in the atmosphere is because of our contribution, humanity's contribution, but that's enough to change the climate radically. So even though it's a small percentage in the atmosphere, 0.04%, it does have a big effect on global climate. Carbon monoxide is a poisonous gas. It interferes with the absorption of oxygen by binding to hemoglobin. This is the thing that people die of during power outages when they have a grill, a charcoal grill burning inside, because that will produce carbon monoxide. And indoor air quality is a big issue with respect to burning fuels indoors, especially charcoal. It can lead to you just simply falling asleep, and it can cause death. And again, because it interferes with oxygen absorption in the bloodstream. All right, hydrocarbons, of course, stuff that comes out of your tailpipe. When you're driving. VOCs are a particular kind that stands for, sometimes called VOX, by the way, that stands for volatile organic compounds. And these are things that you can smell. Volatile means it easily turns to a gas. So when you smell something like nail polish remover or the new car smell, those are usually volatile organic compounds, and some of them can be quite toxic. So you get new flooring put in, or you paint a room and you smell that terrible organic chemical smell. Those are VOCs. You can read more about them here. I'm not going to spend a ton of time on, but let's move on. Actually, it's worth mentioning that some are carcinogens, known carcinogens. The gasoline smell when you're filling up your tank is due to a number of VOCs, but one of them is benzene, and benzene is a known carcinogen. So don't smell gas if you can avoid it. Here's some examples of VOCs, so we can move on. Actually, there are natural ones. That pine smell, pine forest, when you walk through, or your Christmas tree, is a natural VOC. Now, let's moving on to secondary pollutants. Maybe the most important one is ozone. Now, ozone is, remember, there's good ozone. Good ozone high up in the atmosphere absorbs ultraviolet rays and protects us from that cancer-causing radiation. But at ground surface, remember, in the stratosphere is where the good ozone forms, and that can be, 10 to 15 miles up in the atmosphere. So we're not impacted by the good ozone, but bad ozone forms at the ground surface when man-made pollutants react with each other in the presence of sunlight to cause ozone, and then another thing called photochemical smog. So bad ozone is ground surface, and they have those things called ozone action days or code red air quality days. It's usually because of NOx from tailpipes and ozone that forms in sunlight. So we're going to talk a little bit about how ozone forms in just a minute. But remember, there's primary pollutants, things that come out of your tailpipe unaltered, and then there's secondary pollutants, which are as a result of chemical reactions in the atmosphere. So what happens? How does ozone form at the ground surface? Well, it usually happens in the middle of the day. So this is, again, coming out of your tailpipe, nitrogen dioxide. Oops, I revealed that too soon. This is nitrogen dioxide. And that will react with sunlight and split one oxygen off, the NO2, and that lone oxygen atom binds with molecular oxygen, O2, that we need to live, and forms O3. And that's how ozone accumulates it. And yeah, you can think of it as this meme, that nitrogen dioxide in the presence of sunlight is going to split an atomic oxygen off that is going to see molecular oxygen and join up and form an ozone molecule. Ozone is damaging to tissues. It causes respiratory distress. It causes damage to plants. It can cause people with asthma to get some pretty terrible days. Now, lastly, photochemical smog is a tricky set of reactions that has to have three things. You have to have sunlight. You have to have bad ozone or tropospheric ozone at the ground surface and nitrogen dioxide. So again, that's shown here. Sunlight, nitrogen dioxide, and some VOCs present as well, once again from your tailpipe. And so the photochemical smog usually occurs in the afternoon as temperatures rise and the intensity of sunlight rises as well. So it's usually a summertime problem. And again, it really is terrible for people who have asthma because it contains a number of highly reactive molecules, ozone, nitrogen oxides, and all sorts of things. Mexico City is particularly prone to this, as is Los Angeles, because of their geography. It's surrounded by mountains, almost in a bowl, and those materials can sit in that geographically isolated area and just concentrated ground surface, making it a really uncomfortable and unhealthy situation for those residents. Here's a graphic that shows, once again, in the presence of sunlight, nitrogen dioxide is going to split into nitrogen monoxide and atomic oxygen, which finds molecular oxygen to make ozone. And then when you have ozone combined with some VOCs in the presence of sunlight, you get this photochemical smog. And that's the bad stuff. This is a good website that shows, notice, as the daytime increases, right here, so 8 a.m. to noon, the nitrogen oxides increase, but then decrease as sunlight increases, that's shown with the arrow, and forms ozone. So as ozone increases, NOx decreases because part of NOx and nitrogen dioxide is being used up in the formation of ozone. All right, the very last thing, there's a picture of Los Angeles fairly recently, only 3-4 years ago, and you can see that brown, dirty layer of air sitting over the city. That is photochemical smog. Disappears overnight and then forms again the next sunny day. Really terrible air quality. And I'm going, again, the sources in Los Angeles in particular, but everywhere, is really transportation, trains, planes, and automobiles, and industrial manufacturing. Now, industrial smog is slightly different because of the chemistry. Industrial smog is usually related to coal burning. And so there's sulfur dioxide in the air, which of course reacts with water and forms sulfuric acid, acid rain. And so you've got soot and acidic water in the air, and it causes some really terrible respiratory distress problems. So it's usually in areas where coal and heavy oil is burned. And if you look at that film about Linfen, China, is a highly industrialized area, manufacturing hub for China. And so there's an awful lot of coal burning that goes on there and leads to industrial smog. And here again is a summary of the differences. But mostly note that photochemical smog is a place that happens in big cities with lots of people driving, whereas industrial smog is associated with factories. And I believe that's it for the day. So why don't we pause here? And I hope I'll talk to you again soon.